Hello, good morning to one and all. Yeah, today we are going to deal with engineering graphics. In that, we try to deal with the chapter called projection of planes. I hope all of you understood projection of points and projection of straight lines. It is just continuation of projection of points and then a projection of planes, projection of lines. So, myself, Dr. Mahesh Davanageri, Associate Professor in the Department of Mechanical Engineering, Sayadri College of Engineering and Management, Bangalore. So, basic introduction about the planes. What do you mean by planes or a lamina? A plane is an object which is having very a small thickness and large area. Such objects we call as planes, and or you can say that laminas. Sometimes, and we deal with regular planes or laminas. What do you mean by regular planes? Regular planes means if the object or the plane is having all the sides and all the angles are equal, then we say that those are regular planes. In our syllabus, we have only regular planes projections like hexagon, pentagon, triangle, rectangle. Such objects are kept in the first quadrant, giving some orientation, how it looks in the front view, how it looks in the top view. For the given position we have to draw. So these are the some of the objects you can see in the diagram. This is a circle, circular lamina, square lamina, triangular lamina, rectangular lamina, pentagon, hexagonal lamina. You can see in the this is what I can say that it is a square lamina. This is a square lamina. That means all the sides are equal. Similarly, this is a triangular lamina. You can see this. This is a triangular lamina. It doesn't have any thickness. Only it's having an area. You can all you can observe it. Similarly, I have another object. Can you tell me what is this? This is nothing but a hexagon. Okay, 6 sides are there. Okay, so again it is having an only area, but it doesn't have any thickness. Such objects we call as planes or a lamina. And regular planes means, as I told, all the sides of this lamina are equal inside and having an equal angles. Such objects we call as regular laminas. Okay, similarly I have, so in this chapter we have to use some of the important terminologies. So important is, if I take an example of a rectangular lamina as you are seeing in the screen. So it is having a 4 sides, we also call as edges. These are edges, 1, 2, 3, 4 edges are there. If the rectangular or a square lamina is there, it will have 4 sides or 4 edges. Similarly, you can see this, it is having corners. Okay, each will have in this square lamina, it will have 4 corners. If I take an example of triangular lamina, it will have 3 sides and 3 corners. Okay, 3 sides and 3 corners. If I take an example of pentagonal lamina, 5 sides, 5 corners. Hexagonal lamina, it will have 6 sides and 6 corners. Whereas circular lamina, if I take an example of circular lamina, it doesn't have any edges or corners. It will have a circumferential point. We have to keep the object, or you have to give the orientation such that it should rest on one of the circumferential point. So these are some of the terminologies generally we use, either edge or corner. Okay, I hope all of you understood. So coming to the conditions. Okay, so while solving the problems, you can see these sentences or these statements or these conditions regularly. So first is, I will take first one by one. So plane is resting on one of its edge on HP, one of its edge on HP. So if you have to keep, if I take an example of a triangular lamina, this is the triangular lamina. Okay, I assume that my hand is HP. Okay, so in the beginning I have to keep the object in such a way that it should be parallel to HP. it should be parallel to HP, on HP, such that the side on which I want to rest, suppose this is the side, this is the side, this is the side I want to rest, this is the side I want to rest, that should be perpendicular to VP, that should be perpendicular to VP. That means if I have a vertical plane here, so this is a horizontal plane, I have to keep this object in such a way that it should be parallel to HP, on HP, and the side on which I want to rest, that must be what? Perpendicular to VP, or you can say that perpendicular to the XY line. So I have to keep the object, if I take, for example, if I take this is horizontal plane, I have to keep the object like this. All of you can see this. So you can see that, you can see here this side is perpendicular to VP and I want to rest on this side, that is an AB side I want to rest. Similarly, if I take example of square lamina, okay, so again there will be a 4 side, I have to keep the object in such a way that one of the side that I want to rest on HP, that must be what? Again perpendicular to VP, that means I have to keep the object parallel to HP, on HP, such that one of the side is perpendicular to VP. So similarly, there is this side is perpendicular to VP. Here you can see that this is also perpendicular to VP, this is also perpendicular to VP. Either I can use this one also, but generally we follow one condition, we always, whichever I want to rest side, that side is taken left side. Okay, so similarly here if I look at the pentagon, this side is perpendicular to VP and it is parallel to HP and on HP. Similarly, this is the hexagon. Okay, so this hexagon side is perpendicular to VP here. Okay, how to name these things? If I look at this diagram, okay, when I kept on horizontal plane, okay, if I give the namings, this is A, this is B, this is C. When I look from the top, when I look from the front, it appears as this much of straight line. You can observe here, you can appear at this much of straight line. So you are looking from this end, A is first, B is second, sorry, B is first, A is second. Here there is no behind point, C only. So B dash in the bracket A dash, C is as it is. If I take example of square lamina, if you like look at this, and I give the naming A, B, C, D. Okay, so it is on the horizontal plane. Okay, when I look from the top, a true shape is completely visible. Okay, it is, I kept on in such a way that it is parallel to HP, on HP, parallel to HP, on HP, such that one of the side, this side, you can say that AD side is perpendicular to VP. In this position I kept on the horizontal plane. When I look from the top, A is visible, B, C, D, it is nothing but A, B, C, D, you can see here. Okay, when I look from the front, I am looking from this side, it appears as this much of straight line on the XY line. So this is nothing but this straight line. Okay, so giving the naming top view A, B, C, D. So to write front view, A is first, D is second, A is outside, A dash, D dash in the bracket, B is outside, sorry, C is outside and B is outside, C is in the bracket. Similarly, pentagon, you can see that A is visible for you because you are looking from that, E is behind it, just you write it like this, B first, D second, C dash. Similarly for hexagon. I hope all of you have followed this. Okay, coming back to the second condition. So that is what I talked. Okay, let's continue. Okay, plane is next condition is plane is resting on one of its corner on HP. So already you have seen how to keep when the lamina is or plane is resting on one of its edge on HP. Now we will see how we have to keep the in the beginning, that is the initial condition, when the lamina is resting on or plane is resting on one of its corner. You take an example of a triangular lamina. If I take a triangular lamina, look at this, this is in a triangular lamina. There are 3 corners. If I look at this, this is A, B, C. Okay, these are the 3 corners. I want to rest on one of its corner. I may choose any one of the corner. Okay, suppose if I choose this corner A, okay, I have to keep the object in the beginning since it is resting on one of its on corner on HP. I have to keep the object in the beginning. It should be parallel to HP. Okay, it should be on HP as you have done in the previous case. Okay, only change is the corner should be on the left side you want to rest, and the corner and the line joining the center, the corner on which you want to rest and the line joining the center must be parallel to both HP and VP. That means to say that in HP also it should be a true length. Okay, in VP also it should be a true length, or you can say it should be parallel to both HP and VP. Okay, so in the beginning you can see in the screen. So here this is the corner A and this is the line joining center. This line is parallel to both HP and VP. Okay, so in the beginning I have to keep like this. If I take example of a square lamina, this is the corner I want to rest. I have taken on the left side. Okay, and that the line joining this to the center is again parallel to this XY line. Parallel to both HP and VP means it is parallel to XY line itself. Similarly, this is the corner I want to rest, and this is the line joining the center and it is parallel. If I take hexagon, you can see this is the corner I want to rest and the line joining the center is this one and it is again parallel to this. So this is how I can keep in the beginning before to solve the problems. I have to keep the object in such a way that whenever you want to rest on one of its corner, the corner I want to rest and the line joining the center must be parallel to both HP and VP. That means to say that it must be parallel to XY line. So, and I have to take on the left side. It is a general convention. Okay, so I will move to the next step, next condition. Suppose if the lamina is resting on one of its side on VP, okay, in the beginning you have studied the side on HP. Okay, now I am telling side on VP. It is exactly opposite to this. Okay, how to say that? Now I have to keep the object in such a way that it should be parallel to VP, on VP, and one of the side. Suppose if I take example of this rectangle, A dash D dash is perpendicular to HP. Now it is perpendicular to HP or perpendicular to XY line. You can see just it is exactly reverse of this. Okay, this object will be in here and this will be the line will be visible on the XY line. You can see here pentagon. Okay, this is the side. Okay, again it is perpendicular to HP. That means to say that it is perpendicular to XY line. Okay, I have to keep the object in such a way that it should be parallel to parallel to VP, on VP, and the side on which I want to rest, that must be perpendicular to HP. It means it is perpendicular to XY line. So this is it may be for any lamina, it may be triangle, it may be hexagon, any lamina, the conditions remains same. Okay, similarly I will take fourth condition. This is the last condition. Plane is resting on one of its corner on VP. Here it is again reverse of what we talked in the earlier. It should be parallel to VP, on VP, and the corner and the line joining the center, it must be what? Parallel to both HP and VP. You have to keep in the beginning like this. So if, for example, you can take hexagon also here. This is the line. So this is center. Okay, and this line must be parallel to the XY line. So these are the four important conditions, and before solving any problem we should know. Okay, I hope all of you followed. We will continue with this. Okay, so next is, so before solving the problem, when I look at the problem, these are the very important points you should know. First I should decide from I have to start the problem from HP or VP. Okay, that is the main question. So in the problem always I have to look out for the where the surface angle is given. That means whether surface angle is given to HP or VP. If the surface angle is given to HP, start the problem from the HP. If the surface angle is given to VP, then start from VP. Okay, this is very important. Then once you know that surface angle is given to HP, you have to start from HP. Then you have to look for whether it is resting on edge or corner. So based on that, earlier what we discussed, you have to draw the initial position. Then always you have to consider surface angle first. Always you have to consider surface angle first. Then you have to give the inclination of to the plate for the surface angle. Then other angle you have to take in the later stage. These are the important conditions you should follow before solving the problem. I repeat those things. You have to decide whether I have to start from HP or VP. It will be mainly based on the what? In the problem where the surface angle is given. Okay, if the surface angle is given to HP, start from HP. If it is surface angle is given to VP, you start from VP. Okay, then always surface angle must be considered first. Always surface angle must be considered first. And other angle should be taken in the later stage to solve the problem. I hope all of you followed. Okay, so just we'll try to solve the one problem so that you can understand what all the things you have learnt in this case. So look at this problem. A equilateral triangular lamina of 25 mm side lies with one of its edges on HP such that surface of the lamina is inclined at 60 degrees to HP. The edge on which it is resting is inclined at 60 degrees to VP. Draw the projection. Okay, so we will follow the step by step procedure. Okay, first I have to decide whether I have to start from HP or VP. Now just as I told, you look at that surface angle is inclined to HP. That means I have to start from HP. That means I have to start from the horizontal plane. Okay, then second condition, you can just look that it is resting on one of its side on HP or edge on HP. So that means I have to start from HP in such a way that I have to construct the triangle, equilateral triangle, in such a way that one of the side, this is the side I want to rest, AB is the side I want to rest, that I have taken on the left side. Okay, and it is perpendicular to XY line. So perpendicular to XY line or perpendicular to VP. I have to keep the object in such a way that it should be parallel to HP, on HP, and the side on which I want to rest, that must be perpendicular to VP. Here it is BA is perpendicular to VP. I have constructed this one, then projected. Okay, you can see here the line on the XY line, how it looks as a straight line. So giving the naming BAC. So B first, A second, B dash, A dash in the bracket, C. Okay, let's continue with that. Okay, so in the beginning I told I kept on this horizontal plane. So this is the side I want to rest. All of you can see this. Okay, what I will do is I will lift this on this. Okay, all of you can see this. Okay, so this is the angle, it is making 60 degrees with the HP. Okay, when I lift it, the same line will also go for 60 degrees. There's in the front view, this is the line, means that will go for 60 degrees. Okay, you can observe here the line is inclined at 60. This line will go for 60 degrees to HP. Then it will be projected here and projected from the horizontal. This A and this A meets here, this B and this B meets here, this C and this C meets here. Then I will join A to B, B to C, C to D, B to C and A to B. So that will give you the top view of the object. That will give you top view of the object. And once I got top view, then he says that the second condition, the edge on which it is resting is inclined at 60 degrees to VP. See, in the beginning edge on which I am resting on the AB. Okay, you can see here this AB, its length is not changed here, the same length is there, that means still it is a true length. Okay, so this line has to make 60 degrees to VP. Okay, what I have done is, in the beginning I will just show again once again. In the beginning I kept like this. Okay, I lifted for 60 degrees. Okay, now still this edge, AB edge, is perpendicular to VP only. Okay, in the beginning I kept like that, but he don't want like that. Okay, in the problem he wants this line must be what? Inclined at 60 degrees to VP. What I will do is, I will just turn this line lamina keeping HP angle as constant, that means 60 degrees, such that this line will become 60 degrees to XY line, 60 degrees to XY line. That means to say that you can just look at this diagram. I have drawn a 60 degree line and I have kept this AB line on that. I have reconstructed this object in such a way that AB is on 60 degrees to VP, or it is 60 degrees to XY line. Okay, so once I construct this one, then I can obtain, by drawing the projection, you can obtain the top and the front view. You can see here this A and this A meets here, this B and this B meets here, this C and this C meets here. Okay, so then join A dash to B dash, B dash to C dash, then I will obtain the front view for this. So this is how I can obtain all the this is how I can satisfy all the conditions for this particular problem. I hope all of you understood. I will take another example. You can just look at this second problem. A square lamina of 40 mm side rests on one of its side on HP. The lamina makes 30 degrees to HP and side on which it is resting is inclined at 45 degrees to VP. In the beginning, again looking at the lamina problem, the surface angle is given to HP. That means I have to start from horizontal plane and I have to keep the object in such a way that one of the side here AB, one of the side AB, this is, if I take, this is a square lamina. Okay, I have to keep on the object such that it should be parallel to HP. On HP, the side I want to rest, that must be perpendicular to VP. I kept in the beginning like this. You can see in the screen ABCD diagram. Okay, and its front view is a simple straight line on the XY line. And if I look at from this end, okay, A is first, D is second, B is first, C is second. So A, D dash in the bracket, C, B and C dash in the bracket. So like this, then I will lift this object on this edge in such a way that the lamina makes 30 degrees. You can see here this angle is 30 degrees, and naturally this line in the front view will also go for 30 degrees. This line will go for 30 degrees. For example, if I take my hand is in a straight line, this will go for 30 degrees. I hope all of you understood. So first what we will do is construct this one, first position, then lift this object such that it should be on the XY line. Okay, the edge on which I am resting, A dash D dash, and making 30 degrees. From this I am projecting it to the top view, projecting from this end. So this A and this A meets here, this B and this B meets here, and this C and this C meets here, this D and this D meets here. Construct it. Okay, this is the second position of the object. Then he says that the edge on which it is resting is inclined at 45 degrees to VP. As I told in the previous problem also, AD is the edge I am resting. Here also it is AD. That length is not changed here. So why I am telling this, that length is not changed, we will come to know in the later stage. Okay, of the some different problems while solving, I will explain that one. So this AD is right now perpendicular to VP. Right now, because I kept in the beginning like that. Okay, to solve the problem, AD is right now perpendicular to VP. That line I don't want perpendicular, he wants that must be what? Inclined at 45 degrees to VP. So reconstruct this object in such a way that that AD line is inclined at 45 degrees to VP. 45 degrees to VP. So draw 45 degree line, reconstruct this one on that line such that AD should be on 45 degree line. Rest all you construct it, then project to the front view. A is projected, B is projected, C is projected, D is projected. Then A and A meets here, B and B meets here, C and C meets here, then D and D. Then if I construct, I will get the top view of this. So here you can see that throughout the problem, since I am resting on one of its side, that AD edge is must be on the XY line. AD here also, AD here also, AD here also. In all the three figures, that edge is on the XY line. That means it is in a correct. Okay, I hope all of you understood this problem. Then I will take last problem, that is for this today's class. Okay, a pentagonal lamina of 25 mm side is resting on one of its edge on HP. Okay, such that the lamina makes an angle 60 degrees to HP and edge on which it is resting in is inclined at 45 degrees to VP. So again, surface angle is given to HP. Start from HP, keeping one of the side perpendicular to XY line. Just look at the screen. Okay, AE is the line which is perpendicular to VP. In the beginning I kept like this. Obtain the top view, front view, then lift the object on the edge, okay, such that the inclination is given. Okay, similarly same way the line is also going. So that line is making 60 degrees. Then draw the projections here. Okay, then join these things. Will have a pentagon. A reduced pentagon will have. Again, the edge on which I am resting on AE. That must be what? 45 degrees. Draw 45 degree line. Okay, reconstruct this second object on this 45 degree line such that AE must be on 45. Okay, then draw the projection from all the points of this pentagon. Draw the projection from this, then obtain the front view for this. I hope all of you understood. So thank you so much.